Okay, so welcome to today's tutorial. You have any doubts to discuss? Yeah. Anything you'd like to discuss today? Exponential location family. What is to be done? No, what is to be done? Huh? UMP alpha test, right? What is your so let me write down the model first. ID with PDF f theta x, which is 1 by sigma naught e to power minus x minus theta by sigma naught, or x greater than theta, right? Theta belongs to capital theta, which is whole R. Sigma naught greater than 0 is known, right? And what is your hypothesis? Which problem is this? Which assignment? Assignment 7, problem number? Problem number. So you have to test s equal to theta is equal to theta naught against theta is equal to theta 1, right? So hypothesis is theta is equal to theta naught. Problem 1 you are talking about, right? Oh, problem 4. Let x1, x2, xn be random sample. We have in each of the following cases find the test function based on minimum sufficiency t and having the same power function as the test phi. So, and you're talking about part 3, right? Okay. So this is problem number 7. Sorry, problem number 4, 3, assignment number 7, right? Whatever null hypothesis and that is there, here you don't need null hypothesis, or you are given a test. Your phi x one if x2 is greater than 1 and 0 otherwise, right? Now what you have to do is you have to find a test based on minimum sufficient statistic which has the same power as this, and you know that that test is nothing but expected value of phi given t, right? So first of all, what is the minimum sufficient statistic in this case? X1, right? So X1 and you know that the desired test is phi star x. And how do you determine this phi star x? It says take expected value of this conditional on the minimum sufficient statistic, right? So expected value of phi x given t. Is that okay? That is what we had seen in the lectures, that if you have a test which is not a function of a sufficient statistic, you can condition it and take the expected value. This is clearly a, now the one question arises, is it a valid test function? This would be a valid test function only when it is between 0 to 1. and it should depend only on observations. Phi was a valid test, so it is clearly between 0 to 1, because expected value of a function which is between 0 to 1 would be between 0 to 1. And since t is sufficient, conditional distribution of x given t does not depend on theta. So it is not going to depend on theta. This is going to be a proper valid test function. So this is what you have to find it out, right? So let's try to find out what is expected value of phi x given t is equal to t. What is nothing but expected phi x is same as probability that x2 is bigger than x1 given that x1 is equal to t. Can't you find this now? You can do it so many ways. X2 greater than v, what does that? X2 greater than 1, what does that mean? Under what condition you can have x2 greater than 1? What happened? Right. It only says x2 is bigger than 1, right? Certainly all other order statistics are also bigger than 1, right? X1 can also be bigger than 1. So there is a possibility that x2 to either all n minus 1 are bigger than 1 or all n are bigger than 1. Can also that happen. But because it is a conditional distribution, it's better to deal with a conditional distribution rather than because you know the distribution of order statistics, right? X1 and x2. So you know the distribution of x2 given x1. You can find it out. So what is the distribution of x1, x2? Let us say at S and T. This you know. What is this PDF? Yes? PDF of RS and SS order statistic. Yeah? You don't remember? You didn't do this before? Huh? Right. I think you people don't use your statistical mind at all. You have a dumb statistical mind, right? You see, even if you don't remember the formula, it's not a very rocket science, right? It is saying that x1 and x2, your PDF at S and T. Even if you use the statistical mind, what does it say? First of all, S has to be less than T, right? Otherwise, there could be a problem, right? Now, what it says, here it is S and here it is T. X1 is over here and x2 is over here, right? X1 is at S and x2 is T. Now it is a continuous, so probability of x1 is equal to S would be 0, probability x2 is equal to T is 0. But whenever we talk about continuous distribution, we mean that x1 is taking value in an infinitesimal small interval around S, right? So that means x1 is lying over here, T is over here. So that means how many are over here? So these are like a multinomial cells, right? I am saying one of them, because this is going to be an infinitesimally small interval. So probability of more than one observations there is going to be almost negligible. So that can be forgotten about. So that means how many cells you have? 1, 2, 3, 4, 5 cells, right? One cell on the left of S, one is exactly S, one cell is between T to S, one cell exactly T. When I'm saying exactly T means infinitesimal small interval around T. And one is over here. Now x1, what I'm saying is these xi's are IID. They can randomly be put into these cells because they're IID. So what I'm talking about, how many would be over here? 0. How many over here? How many over here? How many over here? 0. How many over? So multinomial probability, right? Multinomial probability now factorial n. Same argument holds for R and S, right? If it was R over here, they would have been R minus 1 over here, right? Factorial n, factorial 0, factorial 1, factorial 0, factorial 1, factorial n minus 2. Is that okay? What is the probability that one particular observation falls here? It is less than S. What is the probability that x1 less than S? That means distribution function f of s, right? Probability that any observation less than S is f of s. So f of s to power 0. Probability of exactly in infinitesimal interval around x1, we can take that as a density itself, f of s. Right? That will be f of s plus delta minus f of s by delta. So f of s. What will be this? F of t minus f of s to power 0. One over here, f of t, and n minus 2 over here. What is the probability of observation being over here? 1 minus f of t. Okay, so this is nothing but n into n minus 1. All right, fs to power 0, fs as 1 minus ft to power n minus 2, fs ft. Is that okay? Now s is less than t, so this would be positive only when s is bigger than theta, right? Because it's exponential. S is greater than theta. So this would be for s less than t. What is 1 minus ft? It is exponential, right? E power minus t minus theta by sigma naught. So it is e to power minus n minus 2 t minus theta by sigma naught. Is that okay? Okay. Then f of s is 1 by sigma naught e to power minus s minus theta naught, s minus theta by sigma naught into 1 by sigma naught. Because for s bigger than theta, theta less than s less than t. Is that okay? So this becomes e to power minus n minus 1, right? But anyway, I have to find a conditional PDF of x1 given x2, right? x2 given x1. This you can put as s, doesn't matter. Because x1 I'm putting at s over here. T is equal to s. What would be this? Anyone? Should I calculate the marginal? See, what he's saying is this would be same as joint and marginal. That means you'll have to calculate the margin. Can I avoid calculating the marginal? So then you ask me to go back over there, right? I have already traveled this much, right? I don't want to go back. I'm saying over here, he says, now from here you should calculate the marginal to get the conditional PDF, right? I'm saying my question is, can I avoid using the marginal? Let's see. You see, marginal, why do you need? Marginal would be a function of S. And S is fixed. So that would work like a normalizing constant only. If there is a marginal, because S is fixed, it would be marginal at S. And since S is fixed, it would work like a normalizing constant. And normalizing constant, I can always determine otherwise why to calculate an integral. So what I say is, this would be proportional to, because marginal would be your normalizing constant, right? So I'm saying this is proportional to. So this would be proportional to the joint, right? Joint of this and this, but I consider this as only a function of t, because S is fixed quantity, right? I don't care about. So let's see what happens. This as a function of t. All known quantities I'll get absorbed into this proportionality sign. So this is proportionality sign absorption. Here also it will get absorbed. This will also get absorbed. This will also get absorbed because S is fixed, theta is fixed, sigma naught is fixed. So what is left? E to the power minus n minus 1 t minus theta by sigma naught. And in fact, this also I can absorb in proportionality constant. So it is only e to the power minus n minus t by sigma. What is the range for t? Because S is fixed. So the range of t is, for a fixed S, t greater than S. Now tell me what should be the proportionality constant. It again looks like exponential only, right? So I know that this is going to be, because t is bigger than S, so it is going to be e to the power minus n minus 1 by sigma naught, t minus S, and n minus 1 by sigma naught. I did not calculate the marginal, right? Is that okay? Because that proportionality constant has to be there, right? Nothing else. So you see, wherever you have to find a conditional distribution in BSc, you must have to write down the joint, then calculate the marginal, then divide it, and so on. There's no need to do that in math, especially if your distributions are standard. Okay, now once it is there, then you can find it out what this probability is. So expected value of phi x given t is equal to s is nothing but probability that x2 is greater than 1 given that x1 is equal to s. What do you calculate this? How do you calculate this? X2 is bigger than 1. You know that range of X2 is bigger than S because S is fixed. So S is over here. Now it depends where your 1 is. If 1 is over here, what would be this probability? If 1 is less than S, then what would be this probability? Why? Because range of T is always bigger than S. So if 1 was over here, what is the probability that x2 is bigger than 1? It is 1, right? So this is 1. Sorry, 1 if 1 is less than s. Is that okay? And if s is bigger than 1, then I know that range is this. If 1 is bigger than s, right? range is over here, and you're talking about what is the probability that x2 is bigger than 1. So that means you have to integrate from 1 to infinity. And if you integrate this from 1 to infinity, what do you get? E to power minus n minus 1 by sigma naught into 1 minus s. Okay. So this is the desired test, right? So what is your desired test? So this is phi star x basically turns out to be 1. If s is bigger than 1, that means s was my t, which is x1. And this is e to power minus there's some problem, right? There's some problem somewhere. T is s is less than 1. This will coming out to be more than 1, right? What would be its e to power minus probability f bar greater than t would be e to power minus. Yeah, that's okay because s is bigger than 1. So x1 is less than 1. That is okay. Then it is nothing but e to power n minus 1 minus x. Is that clear? This is clear? So it is a note that original test was, what was your original test? Non-randomized, because it was taking only 1 and 0 values. Yeah, what was your original test over here? It only takes value 1 and 0. But the equivalent test which you got, which has same power function as this, is a randomized test. Right? Especially when x1 is less than 1, it says you do a randomization. And randomization is based on what you observe, x1. Is that okay? Any other doubt you have? Well, 8 of same assignment, right? Eight. Let P0 and P1 be joint density PDFs. That's what you're talking about? Okay, 8 of part 1. Seven and 8, both you want, right? Okay, let us look at the 7th uniform theta theta plus only I did in the class. Acha, let us do. See, by the way, you're not expected to do all the problems. I'm giving a lot of problems. That doesn't mean that you have to do all the problems, right? The purpose of giving these many problems is you can browse through it. A lot of problems you would say that this is straightforward, I can do it, and that you need not do it, right? Huh? Yeah, so that is the purpose, right? So problem 1, 7 interaction, right? Okay, so f of theta x is 1, right? If each xi is between theta to theta plus 1, right? That means x1 is bigger than theta. And xn is less than or equal to theta plus 1. Right? That means, yeah, theta lies between xn minus 1. So one thing you should note over here, under this model, the maximum difference between xn and x1 can be how much? 1. Right? Because they are in a unit interval. So the maximum difference between xn and x1 can be 1. So I have to consider h naught. Theta is equal to theta 0. Theta is equal to theta 1. Right? Let us consider delta x. K times, let us say, f theta naught x. Which way, how much? So you see, one is theta 1 and one is theta naught. So I have to consider two cases, whether theta 1 is bigger than theta naught or theta 1 is less than theta naught, right? So case first, theta 1 is bigger than theta naught. Then under theta 1, I know my interval is theta 1 to theta 1. Under theta naught, my interval is theta naught to theta naught plus 1. Now they may overlap, they may not overlap. So again, further two cases would arrive. The first case is theta naught and theta naught plus 1, because there are two distributions, right? And they are uniform in theta, so theta plus 1. So this is the case where two are overlapping, non-overlapping. And this is a case where theta naught is less than theta 1 minus 1, or theta 1 is bigger than theta naught plus 1. So this is a case where theta 1 is bigger than theta naught. Now this test we have seen, this is a trivial kind of thing, as I've said. This, even if you give to a person who is totally statistically illiterate, he will say, I'll reject h naught if my x is bigger than theta naught plus 1. So in fact, tests are not going to be uniformly most powerful, right? Any test, somebody may say that I'll reject if my observation is maximum is bigger than theta naught plus 1. Maximum b is bigger than theta naught plus 1 plus theta 1 by 2 and all that, right? But still, if you want to do it mechanically through Neyman-Pearson lemma, what would be this quantity? So in this case, I know that my f theta 1x my x1 and xn, because maximum difference between x1 and xn is 1. Right? Maximum difference between them is 1. So where my x1 and xn can lie? So look at what are the possible values of delta x. So you see, if x1 and xn both are over here, x1 and xn both are between theta naught to theta naught plus 1. What? What is that? Condition is saying other things? No, which condition? Oh, theta 1 is bigger than theta naught plus 1, right? So this is theta 1, this is bigger than theta 1 is bigger than theta naught plus 1. Only it is bigger than, yeah, that is okay. So this is a situation where theta 1 is bigger than theta naught plus 1, right? So there are various situations. Let us look at delta x. If x1 and xn both are over here, then what happens over here? It is minus k, right? that okay? And if my x1 and xn both are over here, then this is k. Yeah, this is 1, right? Yeah. What about other things? In fact, the other possibility could be x1 is over here and xn is over here. Right? x1 is over here and xn is over here. The smaller one is over here and maximum is over here, then also it is 0, right? Then both are 0. x1 is over here and xn is over here, then both are 0. So in fact, it is 0 in all other cases. So my most powerful test is going to be of this type. But now k is in my hand, right? There are various possibilities. One is k is 0, I take, right? First consider k is equal to 0. K is equal to 0 means it would be 1 only when this happens. And this is 0 otherwise. So it says you take delta x to be 1 if theta 1 less than x1 less than xn less than theta 1 plus 1, 0 otherwise. So what does that mean? I take phi to be 1 over here and gamma in all other ranges, right? So my test becomes phi x to be 1 if theta 1 less than x1 less than xn less than theta 1 plus 1 and gamma otherwise, right? And how do I choose my gamma? So that level is alpha, right? So I choose E theta 1, sorry, E theta naught phi x is less than or equal to alpha. What would E theta naught phi x? What would E theta naught phi x? Why under theta naught it is uniform theta naught to theta naught plus 1. So this probability would be anyway 0, right? So it would be gamma times the whole probability 1. So this requires that gamma should be less than or equal to alpha. So you take any gamma less than or equal to alpha, put it over here, it would be uniformly most powerful test. So you have infinitely many uniformly most powerful tests. Right? This is a situation where you can choose any gamma. If alpha is between 0 to 1, there are infinitely many choices of gamma. What is the power of these of tests? Interesting thing is, power of these tests is expected value under theta 1. Under theta 1, this probability would be 0. So it would be always 1. So all of these tests would have a power 1. So which one would we prefer? Among all these, which one would you prefer? Although they satisfy all of them are UMP alpha. But which one would you prefer? One would, yeah? Gamma is equal to 0, right? And that is what I said. You don't need statistics person to do it. He would write in the beginning, would say, if my x1 and xn is over here, you reject the null hypothesis, right? Probability of type 1 error is 0. Probability of type 2 error is 0, and that is because the fact that this is 2 are mutually exclusive. They don't have any common support. Still, you can consider many more uniformly most powerful. I have only considered k is equal to 0. The other possibility is k is positive. K is positive, then what happens? Then phi x is 1 if this happens, and 0 otherwise. Phi x could be 0 now when it is negative, which is covered in a sense over here. You can take gamma to be 0 in that case, right? Any doubt here? Something is bothering you? You see, this K, as I said, is in my choice. One choice is K is equal to 0. K is equal to 0, I said it works, and it gives me infinitely many uniformly most powerful tests. But K is in my hand. I should keep on trying my K. K is anything bigger than or equal to 0. So let us take K to be something positive. K to be positive, then delta x is negative in this range, and positive in this range, and 0 otherwise. In fact, your x1, xn would be here or here. This case doesn't arise, in fact, if you look at it. Right. So that means phi x would be, my test would be 1 if this happens, and 0 if this happens, which would be same as this by taking gamma is equal to 0, right? Okay. And I said any gamma between 0 to alpha works, right? Yeah, so you want me to do the case 2 also? Okay. Case 2 is theta 1 is bigger than theta naught, but they have common. Theta 1 and then theta 1 plus 1. So let us look at delta x, f theta 1 x. So what happens? I know my x1 and xn both can be either here or here, right? Both here. So one possibility is my x1 and xn both are over here, right? X1 and xn both are between theta naught to theta 1. So let us look at what happens in that situation. x1 less than xn greater than theta naught less than theta. That is possibility because my x1 and xn can be anything over here, so they can be here itself. What happens in this case? F theta 1 minus x minus k times f theta naught x. Yeah, 1 minus k, right? Both are 1, no? Oh, it is theta 1 is 0, so this would be nothing but minus k. The second possibility could be x1 is over here, but theta 1 is between xn is between theta 1 to theta naught plus 1, right? So theta naught less than x1 less than theta 1 less than xn less than theta naught plus 1. Is that okay? What would be in this case? This would be 0, right? Because x1 and xn both have to be. This is a case where x1 is over here and xn is over here, right? So theta naught is possible, but x1 is since over here. This theta 1 to theta 1 plus 1 cannot be there, so that would always be 0, right? It will be again 1. Sorry, minus k. Is it okay? This will be again minus k, right? Where? Yeah, because you see f theta 1 is positive. F theta x is positive only when x1 and xn are between theta to theta plus 1. Otherwise it is 0. No? So you see, if you look at f theta 1 x minus f theta naught x, you see one way to do it, you can go enumerate like this. Other thing is, I try to look at under what conditions this is negative. That means f theta 1 is 0. F theta 1 would be 0 if it doesn't fall in theta 1 to theta 1 plus 1, right? Any of them. Either x1 is outside or xn is outside. Then f theta 1 is 0. So that means x1 and x1 is over here, or okay. So yes. So if x1 and xn does not belong to theta 1 to theta 1 plus 1, then this quantity is 0. This can also be 0 when it doesn't belong to theta naught and theta naught plus 1, but those cases I am not considering, because I would consider only when x1 and xn belong to either theta 1 to theta 1 plus 1 or theta naught to theta naught plus 1. See, what I'm trying to emphasize is, I know because I have only two distributions, theta naught and theta 1. Either theta naught is true or theta 1 is true. So either x1 and xn both are between theta naught to theta naught plus 1, or both are between theta 1 to theta 1 plus 1. Then only they would be. So what is happening over here is, I should consider x1 and xn either over here or over here. I am considering now various possibilities which can arise over here. Right? That is what I had said. What I am saying is x1 and xn both. First I fix x1 over here. Right? If x1 is over here, I think it's better that you do it from the first principle, so that you don't make any mistake in enumerating, right? Otherwise, there's a possibility that you may make a mistake in enumerating. So first thing is my x1 is over here. That means x1 is between theta naught to theta 1. What are the possibilities for xn now? Xn can be here or here. That's all. Because x1 and xn have to be either both in theta naught to theta plus 1, or both have to be in theta 1 to theta 1 plus 1. Beyond this, xn cannot go. So x1 is over here. So that means the first case arises, xn lies between theta naught to theta 1. What is happening in this case? F theta 1x is how much? Because xn is lying over here, so f theta 1x is 0. So it is only the f theta naught x will come, which is 1, right? So it is only minus k. Okay. Now I consider x1 is over here and xn falls over here. Xn lies between theta 1 to theta naught. What would be in this case? Again here, because x1 is smaller than theta 1, so f theta 1x would be 0. So it would be again minus k. So this is this or this. So I can combine this. What does this give? X1 is between theta naught to theta 1, and xn is less than theta naught plus 1, right? This only gives, if you combine the both, in either case it is minus k. So that means if you combine this, x1 is between theta naught to theta naught plus 1, and xn between theta naught to theta naught plus 1. Then it is minus k. Is that okay? Now I move x1 over here. X1 first I consider over here. Now I move x1 over here. So that means x1 lies between theta 1 to theta naught plus 1. And xn also lies over here. Let us look at. Right? Both over here. Then what happens? It would be how much? 1 minus k. Both are 1, right? So it is 1 minus k. Now x1 and xn over here. Now x1 is over here and xn can lie over here, right? So x1 is between theta 1 to theta naught plus 1 and xn lies between theta naught plus 1 to theta 1 plus 1. What happens in this case? Now xn has gone over here. So f theta naught would become 0. So it is 1. Is that okay? Yeah. So x1 all cases are covered. Now x1 is over here and xn is also over here. What happens in this case? F theta 1 would be 0 and f theta naught would be 0, right? So 1 again, right? So that means if x1 is between theta 1 to theta 1 plus 1 and xn is between theta naught plus 1 to xn, this is 1. So these are the three cases arise. Now k is in your choice. Start choosing k. So the first possibility is k you take as 0, right? First possibility you take k as 0. If you take k is equal to 0, what do you get? It is 0 over here, it is 1 over here. So yeah, k is equal to 0. What is the test you get? K is equal to 0, that means this is 0. Here I can take gamma, and rest of the places I take 1, right? So it is gamma if x1 is between theta 0 to theta 1, xn is between theta 0 to theta 0 plus 1. And I've taken k to be 0, right? And this is positive, so 1 otherwise, right? In all other cases. In all other k is equal to 0, right? Yeah, all other cases. And how do you choose this gamma? Gamma is chosen so that what I want is E theta naught phi x should be less than or equal to alpha, right? That is what I want. What does that mean? That means gamma times probability under theta naught, that theta naught lies between theta naught lies between x1 to theta 1. And xn lies between is that okay? You can calculate this under h naught, because under h naught theta 0 and theta 1 both are lies between 0 to 1. What? This is the case. Yeah, theta naught plus 1, yes. You can calculate this, or yes or no? You see, one way is you can find the joint PDF of x1 and xn and you can integrate it. There is no issue in that, right? Because f of x1 xn xy is factorial n, factorial 0, factorial n minus 2, and then factorial 0 again. So it is n into n minus 1, fx to power 0, then fy minus fx to power n minus 2, right? What is f? It is uniform theta naught plus 1. It is uniform theta naught and theta naught plus 1. So you can calculate that, right? And then you can get this probability, this would gamma would be less than. So you get gamma less than or equal to something, right? Because that would be some quantity depending on theta naught. Which gamma would give you the maximum power? Certainly, you should try to use the maximum liberty. That gamma is equal to will give you the maximum liberty, right? Because then the power would increase. Because if you make gamma less than that quantity, the probability of this reason would shrink, right? Okay. So just calculate this and then. Now the case, what is the other case? K is positive. If K is positive, what happens? Here in this range, it would be 0. And K is positive but less than 1. This would be 1. And what would be this? This would be some gamma. So here again, you will not get a unique UMP test, right? You'll get a lot of UMP tests. Okay, we can have one more session if you want on problem solving. We can, yeah, either we can have one of the extra hours or one of the lectures also we can. Want to have this on Monday, problem solving? Okay. So Monday we'll do the problem solving, and if there is anything needed beyond that, then we can have an extra session. You see,